This one has my new puppy. Look at my new puppy. His name's Phaser. He's a cute dog. All right. Now, this is a creative idea, cavalcade, or whatever you want to call it, smorgasbord, something. Anyways, the point is like, oh yeah, no, I remember that thing that I was talking about, the windmill and the turbo or the proppy thing, you know, that kind of stuff. Anyways, using the principles and the laws and some, you know, stuffs that makes it work really well. We're going to talk about the fact that it's like, oh, you know what? If I do this correctly, I can gain a better advantage over the design. Okay, so my idea was to use solar panels. What? On the shroud? I know. Everybody's like, okay. But it's like, wait, shush. Give me a second. I'm going to have to explain some things about my ideas here before you go a little too far with it and think that, oh, that's cool, but like, yeah, there's an increasing cost, complex, blah, 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 blah stuff, right? You know, that whole thing. So we're going to talk about how that, with solar panels, they usually need cooling. Well, now you have a freaking, you know, continuous amount of wind cooling it, which is usually pretty cool. And these little stator, you know, blades that are inside of it that are helping to reduce those vortexes into a increased degree of efficiency, but also flow, you know, rates as well for those blades. If you listen to my, you know, previous video, then you'd know about that. No, but we're going to talk about cool, but caveat, I want to be able to use something more than you might expect. The fluid I'm looking for is something like maybe I need either less electrons, meaning like a sulfur chlorine or something similar, or more. And what I'm trying to attempt is a band gap supercharger. Effectively, the electrons that are going to have this fluid flow are going to jump across and have it act like a catalyst. It produces heat, though, exothermic. It's potential energy. Okay, we get it. Phaser, we get it. Say hi to the camera. Potential energy actualized into what is essentially a dumpage for the electrons, which helps ease the band gap for each one of these designs. Granted, I have to have capillaries and wicking effects, you know, to kind of cool it, but I'm not looking to make it passive, I'm looking to make it active. Okay, before everybody goes, whoa, there's heat here, what are you doing with the heat? And it's like, I have a radiator at the front and I have a radiator at the back. This radiator is no normal radiator. It's a thermal siphon radiator kind of design. It's not the radiators that's a part of the thermosiphon. The the blades, the heat sink blades, are like vapor chamber designs. They are hollow, but with a thermal siphon design wherein as the fluid that's inside that is attached to the fluid that goes into the reservoir and then goes across and then gets dumped into the other reservoir and then sent back is actually a bunch of, it's three different fluids. First off, one is always a liquid. It's a supercritical, so it wants to turn into a gas. One's just a low pressure liquid that'll turn into a gas with a little bit more heat. Another one's just a gas that's soda bubbled into it. Now, what this does is it potentiates each effect. As the bubble will go and rise through the other gases that are a liquid, they tend to impart energy, increasing the rate of which they will effectively turn into a gas, which typically water mixed with in a low pressure environment mixed with a gas that can become supercritical in that lower pressure environment that is also got a regular nitrogenous or just regular nitrogen gas that's inside of it would provide that kind of result. But the thing is, it's like we've got these two areas and we're going to be using what is I like to call the two-stroke opposed piston design. It's a linear generator that has a coil with an iron nitrate magnet. Because they're really cool and they're on the market now, and I figure why not? Neodymium's cool and all, but have you heard of this thing called iron nitrate? This is the good stuff. You want this stuff. Let me tell you about the stuff that I'm trying to sell you, okay? That I actually don't have any money to put into any company producing them. But, iron nitrate batteries. Now, coils, blah, 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 blah. It's like, wait, what's this? Okay, wait, huh? And it's like, well, it's got to be attached to something, as the fluid that goes and expands into a gas has to move it, and then it has to seal it off. But it's like, I need it to return. So how do I get it to have what is essentially a little miniature version of a crankshaft? And that turned into a piezoelectric nitronol type of wire. So it's like they're on a hinge. The hinge experiences mechanical stress that's producing electricity, but it's nitronol, however you want to produce it, and it will bend like a leaf spring. But then it's like it's heating up on one side, and then it's getting cooled as the gas expands, and so then it'll get pressurized and bend back. And so if I could do that, I can basically create what is essentially a version of a spring crankshaft. Now, it then goes off to get cooled by the heat sink fins, and it's producing as it shakes in a linear generating fashion along with those piezoelectrics, and the nitronol does its job. As it goes off, it condenses. I need it to condense into a liquid that can then come back down into the reservoir that spreads itself across a bunch of these little tiny micro to nano or however size that you can reasonably make them. Little generators that you're going to combine with multiple, either copper or I use MOSFETs. I like field effect wires. Field effect wires are really, really good because I can have a capacitor that will build up and drain together in a continuation of, I know that there's electricity over here that's flowing, but this one isn't, and I can drain it off. And so like an analog-esque design, I can then continuously DC flow series and parallels of these generators together with a greater degree of current and amperage with less degrees of loss outright, which is a good idea, I figured. But it's a radiator. Any other radiator is what you usually assume, but then this is producing electricity from waste heat that is having this fluid flow through it that helps the band gap efficiency and cooling efficiency of your solar panels, which are now around your new windmill, that then also can be started with a basic fan instead of just waiting for the wind pressure to get good enough. And then it continuously, quotation marks, flows air through it. Quotation marks is real caveat there. It won't can sort of technically. The sun's still shining, the earth's still spinning, there's still heat in that dang atmosphere around us, so I'm pretty sure it should still keep going, although albeit to varying degrees of speed, that kind of thing. Which means I should be able to continuously, as long as there is some degree of sun and wind, keep it going to gain a efficiency advantage and increase degrees of power output from a given area size by extracting as much in a square meter, let's say, of the energy that comes through, meaning the air, because it's kind of like a waste heat generator, kind of. The heat that's in the air from the sun that we don't absorb with the solar panel is kind of what's helping drive that wind along with that vacuum, and so that increases the degree of actual power in the counter-rotating vacuum style fan blade windmill design. And then the electricity produced from the band gap increase is above the band gap limit. Quotation marks. It's cheating. I am cheating my ass off. It's getting it from the the fluid, it's not coming from nowhere. I'm just making it easier, and then it like has an extra, and then it will return because charges exist in the atmosphere. You know what I mean? There is charges in the atmosphere, and as a result of you get the picture. Usually that means I can increase the efficiency of one thing, but I can decrease efficiency somewhere else. Technically, but that heat is now going to drive a greater increase of efficiency for the windmill, which will 100% give me some of it back. Not all of it, but some of it. It'll look like I'm getting more than I should. That's because there's latent heat in the air, which makes it more efficient. Like any other compressor air pump. Not terrible, not great, not amazing. It's a slight degree of efficiency improvement, but then at the same time, for 1 meter square bit of energy for a regular solar panel farm with a bunch of these windmills that are designed specifically to continue pushing air into each other, and the right air intake to increase this effect, an exhaust. I'm heating it up as it comes in, and I'm heating it up as it comes out. There is a measurable degree of captured energy as it goes through. Now, one is good, many more becomes more efficient. And it's basic, fluids. In fact, I wouldn't doubt that a regular the fluorocarbons, I forget which one, but it kind of looks like a methane in a way when you look at their chemical structure where their hydrogen. Anyways, point is, it will allow for a continuation of that band gap increase to a point. The point is, after that point, it doesn't anymore. And in fact, I get releases of this thing called IR energy, which is wonderful for these things called solar photovoltaics that capture IR energy. If you were unaware, it's possible to do that. Being a schmarmy prick about it, but it's like, yeah, no, that's a little bit of efficiency improvement there. But I'm also not. It's just like you got to think about the piece by piece by piece by piece, step by step by step for this. And it's like, it's a little bit more efficient as probably what they'll go with. But in reality, I'm like, it's capturing far greater degrees of energy here, a significant amount more. Because it's continual windmill operation, caveat, quotation mark, like it doesn't really fully do that. Eventually it'll slow down if the vacuums and the wind speed drops below for long enough, a certain speed, it will no longer continue doing that. And it has to initialize itself after that point. So like, it's not it's going to keep going. But with the correct windy area at the right times, it should continue its operation for greater degrees and gain a greater amount of efficiency for simply just strapping a tube that's got some solar panels on it and has a fluid that helps increase the band gap by supercharging it, by allowing for the electrons to essentially want to do that, but they will release a little bit of heat and a little bit of photons, which you're pretty much going to capture, for the most part, into electricity with the linear generator radiators, and with the next fan behind it, which is another Venturi principle. I think it's Venturi, because you can then create the right fan shroud that'll suck in more air as you had the other one, and you get the kind of continuation of the effect to a point. And then it will no longer really push past a certain point. There's only so much heat from the solar panels. There's only so much heat latent in the air, and there's only so much you can capture, from that design. But it's still pretty darn efficient, and I don't see why we wouldn't do it. Outside of the fact that it's like, what's this fluid? And it's like, well, the regular, refrigerant should work technically as long as it has a ionization or an acidic value or alkaline value, depending on the type of band gap increase or area that you're trying to hit. It's all about that little area trying to help that electron excitation occur from photon emittance, essentially, because these photons are going to allow for an increased density of photons in that area, not just help drop down that band gap energy level. And so it tends to supercharge it, like I say, while cooling it, and that heat then also gets transported into more electricity. So it's a pretty decent design. I figured it would be a good idea to do it because renewables are really simplistic. You know what I mean? Like, for what it is. And then I also have like my piezoelectric thermoelectric generating geothermal. Now, see, this geothermal is essentially just a radiator with a bunch of tubes that's thin enough walled with those thermoelectric generating piezoelectric, because earthquakes and vibrations and all that still happen to be there. And then they will have the water pressure of a basin above them that helps drive them down further, and then there's a tube in the inside that will help draw it towards a main turbine tube, and you have a little bit of turbines along the way. All you do is get your oil rigs and you drill a few holes around it, and then you slurry that on out, and then you drop it in section by section, and you continue on, and you have your side piece that will slowly but surely be direction towards your main tube. And you can see where these radiators come in, and the windmills come in, and the solar panels come in, and now we have a significant increase of the overall degree of geothermal extraction energy, because truthfully, we can have this integrated, if it can be done properly, with large enough windmills. Again, it's more efficient for smaller versus extremely large. There's a balance. It's like, too small, you don't get enough vacuum. Too big, the vacuum doesn't change the Cube law theory. Mass is too high. You know what I mean? That's kind of a thing. And so it's like a certain size is really where you're at, but I can just make a radiator any darn size I really dang well please, and that's still going to be a certain amount of degree of energy efficiency gained for those windmills that can take that. Okay, so I feel like it's not a bad idea, and it would basically match the power output potential with a heck of a lot less damage to people and environment of a large amount of the coal, natural gas, incinerator designs we already have, and concepts that are coming out. And then same thing with even some nuclear, it could match. Depending on the size and efficiency of the nuclear fission reactor designs, and even fusion, if we ever get there. I have some fusion design that I've already put out. Feel free to take a look. I will not link it. I'm a douche about that. You can scroll in my video section. So there you go. Please like and subscribe. Have fun. Bye.